Hello, Namaste. Welcome back to the course on Geographic Information System. We were in the module 8. Now, let's look at the lecture 2, which is based on special queries. So, now we have learned how do you create a database, how do you maintain a database. Now, let's look at what do you mean by querying. How do you know how does SQL or the SQL will help you in querying the data from the database, whatever the information that you need from the database. So let's look at this. I'll just these basically what I'm trying to do is that give you just a flavor of how it works. If you want to really get into the advanced mode, I would look each of these. For example, when you are looking at database management system itself is a course, and similarly this querying using SQL or using a PostGIS, all of these are different courses. So, if you want to look at the advanced user, I would suggest taking up these courses and understanding it. Okay. So, maybe I'll just give you a flavor, and if you can take it forward, it would be extremely helpful for you as an GIS user. So, today we would look at what do you mean by SQL or a structured query language, commonly known as SQL or SQL. So, we will look at some of the SQL statements, we will look at how the positioning and indexing is important, and also certain things called as hashing. But other than this, we would look at certain other concepts of how the searching also happens. We will look at R tree, quad tree, etc. So, these are some of the concepts that I would be covering in this today's class. So, when you look at SQL is structured query language, or it is called a standard query language, okay, normally pronounced as SQL, SEQUEL. So, it is called SQL. So, developed by IBM in 1970s. So, now it is a de facto standard for relational databases. If you are looking at their relational databases, by default the query language is SQL, okay, or now the way it is the latest one is MySQL. So, looking at that, if you are trying to understand SQL, it would be very good in terms of learning SQL as an advanced user. Then your database query will be extremely useful. There are three types of usage. One is standard standalone queries. If you just have a small query, so standalone. It can be high level programming. You can look at programming for extraction of information. Most important thing that is happening in today's world is embedding it in other applications, so that it extracts information from users, very similar to those APIs that you use. Okay. So, you embed it into different applications, so then the information is sought. So, when you are looking at SQL statements, there are three kinds of statements. One is the data definition language. So, it creates, alters and deletes data. Okay. Then data manipulation language, it is for retrieving and manipulating data. If you want to retrieve a particular data and manipulate it, then you use a data manipulation language. And when you are looking at control of the data in terms of security, etc., then you have data control language, which is again called as DCL. So, these are three types of SQL statements that are used in terms of using a SQL. So, there is a concept of distributed databases. When I say distributed databases, these are special case of decentralized database solutions, which means to say that all databases doesn't really sit in a particular mesh, in particular workbook or particular place. These are the mesh, these are from various places. If for example, in today's scenario, if someone wants to look at different web pages, so these are very good examples of a decentralized database solutions. You have different web pages from different nook and corners of the country, each having its own database, looking at its own profiles. So, these are different things. There are so many websites which combine all of these together and gives you a single comparative issue. That's again a distributed databases. You have websites doing that issues. So, now the web handling is more of the thing that has been growing in GIS, is similarly with other applications in the computer science. So, systems with distributed database comprises of several databases that are closely integrated with assistance of network and is treated as one unit. Okay. So, sub databases may have different types of databases copies of the same data can be found in several of these sub databases. So, only thing is that data redundancy in case it is not needed. So, that data redundancy is part where you have to maintain it in a much better way, which relational databases normally handles in a very effective way. So, distributed databases have special requirements with respect to common data models, routines for maintaining and checking data quality. So, the way they handle it, the way they maintain it, the way they check the quality is very different. The results in the system to be expensive to run in terms of distributed databases. If you have advantages are increased reliability and access to data, increased efficiency, capacity, advantage of sharing resources. So, all of these are very important in terms of handling a database and maintaining a database. So, when you look at different distributed databases, we have two types, one is homogeneous type, another one is a heterogeneous type. Homogeneous type is divided into autonomous and non-autonomous. So, each of these have their own way of looking at the database. They have been developed for certain issues. I won't get into why, how and how it can store the database, but it is different from each other. That is why there are different groups. Then you have heterogeneous, which is federated, and multi-database. Multi-database is a very common thing that you can find in most of the places. Other than multi-database, it is federated in terms of heterogeneous distributed databases. Okay. So, these are about distributed databases. There are certain advantages, certain disadvantage. When you look at advantage, there are increased reliability and availability at most of the time. Okay. When most of you look at most of the sites, you say you look at what is downtime. Okay, most of the uptime would, if the site uptime is 99.99, then it is considered to be reliable, which means the data that is providing from different databases is reliable. Easier expansion. No, reliability is not just with the time, but you can rely on that particular website for getting the data. That's what I meant. Then easier expansion and local autonomy, whatever the data autonomy you want to have. So, you can look at it locally in a distributed database, and protection of valuable data is easy because each of the distributed database has its own security rules, policies. So, it is easier to segregate data and have different policies, different securities. Cost effective in terms of just maintaining it, but creating it and in a longer run maintaining it is fine, but creating it and in the shorter term it is quite expensive. Okay, but reliable transactions. So, when you are looking at transactions, they are more reliable. When you are looking at disadvantage, the complexity of implementation. So, because you should know everything about the different databases, distributed databases that they are located, and how you have to capture that particular data. So, you need the complexity of implementation is very high. When you are looking at the other disadvantage is the maintenance of integrity of the data, which we mentioned that the first thing that we mentioned in GIS is data integrity. So, that is what is extremely difficult in terms of a distributed database. And if you have inexperienced personnel who are actually handling this distributed database, then you are really going down in terms of maintaining or handling the entire database. It needs a vast experience in terms of how the database is handled. Complex design makes it most difficult in terms of handling, and dependency with other software. So, let us say that each distributed databases has its been developed in their own software systems and the command consoles. So, if you have to look at their software and its interoperability with your software in order to give out the data. So, that is important. Concurrency control challenging. So, concurrency, yes, in today's scenario may not be of much, but yes, it is a challenging task. And most importantly, in the distributed databases, it is lack of standards of representations or standards of storing, standards of representation and integrity. The next thing that we have to look at in this one using a SQL is positioning and indexing. So, see, why I did mention distributed databases in introduction to SQL is that because distributed database SQL can handle any kind of databases. It can be normal database, it can be a distributed database, it just can be a local database. So, SQL can handle any kind of it, and distributed databases are the order of day today, and SQL has a proficiency in handling these data. Then when you are looking at positioning and indexing, when you have a rational data structure, will reduce, if you look at positioning and indexing, will actually reduce your storage volumes. Okay, for example, if you have not positioned or indexed a particular data, okay, it means to say that it is occupying a huge amount of space, and it may also again result in certain duplication of data. Then special techniques have been developed for dividing and structuring data. Generally, map data are stored in a single sequential files, increases response time. So, what they do is they give a multi-sequential file, which means that it is not very sequential. So, because of this, because of the multiple access and or the random access, it will be much easier and faster to access the map data. So, the most important part here is indexing. So, map data are normally indexed in multiple parts. So, that indexing specifies locations. So, keep map sheets are divided into sections which are distributed in such a manner that it can accelerate the search. So, when you are having map data, so most of you will face problems only when you are accessing the huge raster data. Vector data may not be much of a issue, but when you are looking at raster data, they go into volumes. So, when you are accessing a raster data, if it is not indexed properly, okay, you can look at the lag. Click on the vector data, it will open in a second, but if you want to open a raster data, it may take huge amount of time because it may not have been indexed. If you have indexed in multi-part indexing, then probably it will open up at least in 1/10 of the time that it used to open up without indexing. Okay, that's why you need to look at the positioning and indexing. Okay, when you are looking at spatial indexing, there are many ways of indexing. For example, to find out a particular data, there is B tree, there is grid indexing, quad tree, R tree. R tree is basically based on MBR, so it is sometimes very useful, whereas when you are looking at a quad tree, it is based on points and regions, whereas B tree is more of a balanced kind. For example, you have an R tree here. First, R tree starts with the root. You have the most topmost information that is there in the R tree. Then you have leaf nodes. For example, these are the 2D leaf nodes. Then you have the child nodes that digs in, and finally it finds out where the particular thing is stored. It is basically based on MBRs or the multi-boot records. And whereas when you look at a quad tree, for example, if you have this particular image, okay, it divides into four different boxes. So, once it is in the four different quadrants or quads, now it starts looking at that particular quad, then breaking the quads into four different quads and going into those until it finds the particular result. So, this is mostly extremely useful in terms when you have most of the raster data, whereas R tree has now become an industry standards for most of applications in terms of spatial indexing. So, there is the first thing, that early structure that started was a KD tree. So, each level of a KD tree partitions into two spaces. I did show you with the R. So, one dimension for partitioning at the root level, and the next is at the nodes, each nodes. So, there is something called as KD-B tree, extends the KD tree, that is nothing but a B tree, allows the multiple child nodes for each external node, well suited for secondary storages. So, that is why B tree has been extremely useful in terms of applications. You have quad trees. Each node of a quad tree is associated with a rectangular region, that is what I spoke about. The top node is associated with the entire target space. So, that gives you the entire target space or the entire database. Then it goes into different nodes, different data, different worksheets on how the data has to be connected. Each non-leaf nodes divides into region into four equal sized quadrants. Correspondingly, each such nodes has four child child nodes corresponding to 4 quadrants, and so on. So once you have 4 child nodes, it will look at if that is a quadrant. If that is a quadrant, then again divides into 4 child nodes, then until it reaches a quadrant where the search operation halts. Okay. Leaf nodes have between 0 and some fixed number of points. So when your non-leaf node reaches 0 number of expanding child nodes, then it will become a search will come down to that particular value. Just like this, first you have your entire database, so it divides into different quadrants. Once for this is the first quadrant, if you see these are the 1 2 3 4 quadrants. So now it has to find out that particular data. So you have based on relationship data, you have a lot of data that is present here. So first it looks at this particular quadrant, so divides it into 4, then it says that it finds out one particular set of data that is already present. Then there is again the same ID that is represented in another quadrant also, so divide it into 4, so you get 2 more data sets, so you access this particular thing. Similarly, it happens out throughout the entire database. That's how a quad tree or a quad database works. The next thing is R trees. This I have already explained, I won't get into these details, but R trees have now become an extremely useful and have become a standard protocol in terms of developing it. For how does an R tree is formed? First, a rectangular bounding box is associated with each tree node. For example, like this, if these are the different points and this is a polygon, so you have a bounding box, this is a line, so there is a bounding box, rectangular bounding box that is created. Then bounding box of a leaf node is the minimum size rectangle that contains all the rectangles or polygons associated with the leaf node. Then the bounding box associated with the non-leaf node contains the bounding box associated with all the childrens. If there are many more children, then each of them will have bounding boxes. So bounding box of the node serves as a key to its parent node. You don't need to understand all of these in case you are just looking at the GIS in just a holistic way. If you want to become an advanced user, then only you have to understand how each of these R tree, quad tree, etc. works. Okay, the polygon is stored only in one node, and the bounding box of the node must contain that polygon. Okay, so storage efficiency of R tree is better than that of any KD tree or B tree or even quad tree, since a polygon is stored only once, whereas in quad tree the polygon is repeated. That is why the data consistency may not be there. Okay, so this is an example of a B tree. If you want to find out where between P and R a polygon, okay, so you have entirely through A through Z. This is one of those examples that I have adapted from IBM. So if you look at you have an A through Z. So first is such as A will have its sub nodes from A to I. So you have these are this is a leaf node and these are non-leaf nodes. And when you look at a leaf node, doesn't say that this value exists in this, so it looks at this, yes, the value exists, so it goes into the leaf node and digs deep into non-leaf nodes where you find out R. Okay, so this is how a B tree works. This is a general way of how it works, but if you want to look at in more detail, please look at the textbooks which I have already referred. It has extensive explanations of how a B tree works. The next concept is hashing. Hashing, it is a key that is used to locate data physically on the disk. Each map section is assigned a number which are listed in the table of pointers to storage locations. The map section numbers and hence the entries in the index table are calculated based on the Cartesian coordinates. That's how you hash a map and look at it. So how can you do it? For example, if you want to hash, this is one of the formulas that is used in terms of hashing. You need hx of x, hy of y, which is giving you point information in the Cartesian coordinate system. So it divides a map into equal rectangles and each entry into a table is done based on this. Okay, so something like this. Okay, this is how the table is. So you have these values, so based on this, these are the entries that will be made, and this is the index table, and related geometric data would be stored in the other table. Okay, this will help in retrieval of data much faster. Okay, a SQL can have a single query, SQL can have a multiple query. So if you want to have a multiple query, it can handle something like this. For example, state equal to West Bengal or state equal to Kerala, and value greater than 5,000 and a value less than 10,000, which means I am looking at in the state of West Bengal and Kerala, where the population value is less than 5,000 and population value is less than 10,000. So give me all the queries. So this is one way of looking at multiple queries in terms of representation or searching. Then you have for example, you don't know a particular let's say a function or a field, okay, and you know only the partial name of it. So you can do even the partial matches in terms of querying. So for example, if you want to find out all customer names beginning with Mac or Mac, okay, you can even write it as McDonald or McDonald. So how do you write it? It depends on the way it is represented. So it is just if you want to query, so name is equal to Mac and MC. So it will give you all the names that are there, or Mac or MC, so that will give only those names which are there. So find all the zip codes beginning with 6. Okay, all this beginning with 6 will be listed. Okay, so you normally when these are there, partial matches are there, you don't know the other part. For example, McDonald, I don't know the Donald part. Let's say I know only Mac. So I'll write MC star. It means to say that star MC star, which means anything that is previous to MC, anything that is after MC, list all of them wherever MC exists. Even in the entire list, it actually locates. Okay, if there is something like Gunshekaran MC, okay, continuous name, let's say Gunshekaran MC, so it or even list, even if it is MCA degree, it because MC is actually occurring there, so it also lists MCA. Okay, so that's how you can look at the partial match, then select whichever the data you need. Okay, it need not be the same data. Other one is the like operator. For example, if you want to find out there is certain for example, let's say in this example you have name like percentage a percentage, it will find all the names starting with A. For example, if I have a field name that is academicians, so academicians, and I would give the names. So any academicians with starting with A will be mentioned in that particular query output. So if you have percentage, then is the ignore wildcard. Okay, in case you want to ignore it, just add a percentage, so it ignores this particular wildcard. So now if I put it as A, if there is a academician like Amit and Arpita, so both of them will be ignored in this particular set of queries. So you can also query something like this. The name, you don't know exactly that name, so you have to say name like percentage Nagar percentage. It would find Kalyan space Nagar. So you need only Nagar, you don't need something like Kalyan. Okay, so it is only searching for Nagar. So Nagar exists in this Kalyan Nagar and Karunya Nagar, so it gives you the output. But if there is something like Rajaji Nagar or Shivaji Nagar, it won't give it. So if you want to search Rajaji Nagar or Shivaji Nagar, then you may have star Nagar star, so it will give you everything that is in between Rajan Nagar and Shivaji Nagar, including Kalyan Nagar and Karunya Nagar. So that's how the like operator works. Then you have query result. The result of a query meets the standard design of a query. It is how the query has been designed. That is where the database the creator will actually design how the queries are made. So we may use operations. For example, export the queried shortlist objects, mathematically calculate any required value, statistically determine results. So develop outputs such as reports. Only thing is that reports cannot be modified. So based on this, whatever the query you do, this if there is a database administrator has defined the output of a query in a certain way, only in that way the query results will be provided. Okay, then you have certain rules for storage of the database. So now I am stopping with the queries. Now let's again go back to the database. Database has certain storage rules, and fields have specific types available. For example, when you are naming rule, not, I did mention it before, you cannot have more than 13 characters in your database as a name. You can use only letters and numbers, must start with a letter. Once defined, it cannot be named. First, due to certain constraints, many of the databases were not allowing the special characters, but in today's scenario we can use special characters as name of the database. So it cannot have even spaces, so that you should remember. So must be defined before use. When you are creating a database, you have to define the name of that particular database. So these are certain storage rules that you should know when you are creating a database. So there are different datas that database can handle, or queries can be made of. So you have fundamental mode of computer, it uses a fundamental mode of computer storage, something like a binary data. Okay, data are stored as a series of zeros and ones representing the numbers in 2 bits. This you know is a binary data. So bits are grouped by 8 to form 1 byte. 1024 bytes is equal to 1 MB, and 1024 MBs is equal to 1 gig, and so on. Okay, so that's how the binary data can be used. Then you can use it in the form of ASCII. Okay, so normally ASCII is used in alphanumeric storage, or those which are non-numeric, which are numeric. And so when you are looking at storing data, text data always are normally stored in ASCII format. Numeric data may be stored in ASCII or binary. Normally it is binary format. Binary is generally more efficient in terms of storage capabilities. And when you are storing, typically this is one of those examples which many students ask in terms of storage. For example, binary stores it in the form of a whole number. Okay, if you want to store a decimal value, okay, the computer stores in the form of scientific notations. Probably you understand what is a mantissa and exponent. Okay, so it stores always in the form of exponent. For example, this may be a scientific notation. Okay, if this is your scientific notation, the storage in a computer is in the form of a mantissa and an exponent. So always your data is stored in the form of a mantissa and exponent. Okay, so when you are looking at the database storage, so you have to look, you have to typically, the storage, the size of a storage typically depends on two things. One is the ASCII versus the binary type storage. What type of storage is being used, what is those that is behind is being used. Then bytes of storage allocated. So it also depends on the user, how he or she wants to store the data. Then integer versus floating point. Now when you are looking at floating point, there are certain operations where floating point is a must, so use floating point. Okay, definition limits to value that can be stored. There are certain definitions that can limit it. Then important to match types to storage requirements, and try to minimize storage space. That is very important in terms of a database storage. That's why you use compacting. But before you create any field, okay, or storing attribute information, you should know certain things. That is, first thing is what kind of field you are trying to use. If you are using a name, student's name, okay, so are you using a long or a short, or for example you are storing an age of a person, it is long integer, short integer, or that is the way you should know what kind of data you are storing, what is the data type that you are storing, whether it is an integer, it is a float, or it is a string. So how are you actually storing? Well, for example, if it is double, it is double character. So look at the way it has to be stored. First create that kind. So that is why you need to plan it first, what data you are storing, what is the type of the data is available, then only you can look at it. For example, a last name may be very different from number of children in the household. So data that is needed, type that is needed in the last name is extremely different. So when you look at the student grade point average is more of an floating point, whereas number of children in the household is an integer. Okay, so we have to look at how different this data is. Then year of birth, the way it is stored is very different. Okay, the country population. It cannot be, it is in integers. It cannot be your floating point. And aerial image of a country, yes, in a certain format. It's not, you cannot store it in the format as in the above cases. Okay, so before you create any field, look at what particular thing that you are trying to use and what is that field count, how you are looking at the field, what is the data that you are capturing. So then only you create that particular field. Okay, without that it may not be much useful. So we looked at certain what do you mean by structured query language. We looked at some SQL statements, then we looked at positioning and indexing, why it is important. We looked at hashing, then query operations. Okay, how do you actually look at query, and how are different operations, for example like, etc. We looked at it. And finally the database storage, how do you store a database, and very importantly what are the field formats that you have to store and how it has to be stored. So this is all about the SQL and the database. So let's meet in the next class with the next set of different issues. So what I have divided this particular module is more dedicated to developing a database and trying to understand it with different queries. So once I have understood this, I will again go back to the module 5, where would be I will be explaining you certain things about how actually you when you start digitizing, what are the errors you get and how you correct all those errors. That will be in the last lecture of the same module, which I will go back to the module 5. Until so until the next module, have a nice time. Thank you very much.